to discuss today, that is moment of resistance of a rectangular section. As earlier I have told, it will be indicating the capacity of the section, rectangular section, based on sectional dimensions, based on the material, that means concrete, grade of steel, and how much reinforcement area you have provided. Now we can go through this diagram, which is the only stress diagram I have taken. So from this stress diagram, we can calculate Cg and Tg, which we have already discussed by a different formula. Now we can understand here that Cg is a compressive force and Tg is a tensile force. So that's why we have taken arrow in different direction. And now if Cg is equal to Tg for the balance, for the equilibrium of the section, then they will be forming just as a couple, and we can say that they are applying, or section has some movement of a resistance. So this movement of resistance will be against the bending moment. Now if the bending moment due to the loads is more than movement of resistance of section, then we can say that this particular section which is under consideration will not be able to resist the loads which are acting on the beam. And if the moment of a resistance is greater than bending moment, and then we can say that our section is safe in resisting the moment. And this information we will talk later on in details. So what we are here want to understand that Cg and Tg form a couple and create a moment of a resistance of the section. So ultimate moment of a resistance of the section you can get by this formula, that means force multiplied by, that means couple, because Cu and Tg are equal, which we have discussed. Either you can take the value of Cu or you can take the value of Tg and multiply it with lever arm value. So you will be able to get the ultimate moment of a resistance of a section whose dimensions, material, etc. you know. Now we have to check what code is saying, or code is recommending, or code is restricting about it. So therefore we can say ultimate moment of resistance, when you put the value of Cu, that means it is based on the concrete section. So it will be giving you this value, and this formula we can take from the IS code also. And this formula for ultimate moment of resistance is applicable for all value of Xu, or you can calculate it with the help of the steel. So in steel, this is the formula for calculating the ultimate moment of resistance, where Fy, you know that it is the yield strength of the steel, Ast is area of steel, Xu is the depth of the neutral axis. But you have to make sure that this formula is applicable only when either section is balanced section or section is under reinforced, because we are well aware now that code is never recommending over reinforced section. And I appreciate you, all of you, that you have asked wonderful questions so that we are able to discuss your queries. So again, I suggest you as well as encourage you to ask multiple questions so that we can clarify your doubts. Now let us discuss about the limiting moment of resistance. So limiting moment of resistance is, this information is available in IS 456 in Annexure G. Now what code is suggesting us? So this is Annexure G, and that is moment of resistance for rectangular and T section. So we are now getting information regarding the rectangular section. So limiting moment of resistance as per IS code, and condition is when Xu is equal to Xu max. So that type of section you can refer Annexure G and the clause G1.1, where the section without compression reinforcement. So need not to worry, this is this is singly reinforced section. So very first point is code is saying that if the value of xud which you are calculating is less than the limiting value, then you can calculate the ultimate moment of resistance by this formula. And if the value of xu by d is equal to the limiting value, then this formula can be used to calculate the limiting moment of a resistance. And if your xu by d is greater than the limiting value, then your section need to be redesigned.